Hello everyone, welcome to Skills Academy. Today we are going to cover the basics of DCL and some of the advanced topics like indexing, transaction control, views, and basic normalization techniques. To start with, let me just introduce myself. My name is Girish Kavalkar. I'll be instructor for today. I have over 16 plus years of experience in handling data, data engineering, data warehousing across various industry domains. I have successfully led two data warehousing projects in my career span. Apart from this, I am also specialized in handling data with technologies like SQL Server, SSIS, SSRS, Power BI, ADF, Microsoft Fabric, and many more. You can check my career profile on the LinkedIn link on the screen. Before we dive into today's agenda, let us see what we have covered earlier in last 9 days. First, we have covered the introduction of SQL Server. Then we have covered relational databases. Later on, we have covered data types and constraints. Then we covered DML and DDL languages. Later on, we covered on filtering and sorting of data. Along with that, we covered aggregation and grouping of data. We also covered joins. What are the different types of joins in SQL in our previous video, along with subqueries, correlated and non-correlated subqueries. Today we are going to cover a data control language and some of the advanced topics. Let's dive into today's agenda. First, we will see overview about SQL privileges. So what do you mean by SQL privileges? What are the kind of privilege we can provide to user? Then we will see indexes, how indexes are useful for query performance. Later on, we will see transaction control language or TCL. Then we will see some of the concept of views. And at last, we will see basics of database normalization. What happens when you use database normalization? And some of the three normal form we will discuss. So today's session is going to be a little longer. So be follow us. Understanding SQL privileges. SQL privileges are nothing but access given to you or a particular role for accessing SQL objects. SQL objects can be tables, it can be views, it can be function or stored procedure, or a database itself. To give you an overview, the different privileges we can provide access to is select, insert, update, delete, execute, or many more like views, function, stored procedure, like that. Then how SQL privileges are important. So let's say, for example, if you created a database and if all of you or all of the team member can have access to all part of the SQL database, then you will not be aware that who has done the changes. Or if there is a big team, to catch those changes will take some time. In order to do that, SQL privileges will help you to drill down the access. So, for example, if a particular development team wants to access data only for reading purpose, so to them, We do not have to give access for insert, update, or delete. We can just provide a select privilege or a select access to them. Similarly, whenever a particular team is handling data for insert or update, but they are not authorized to delete it, for them, we can provide only those two privileges. Like that, it helps to maintain the data security and data integrity. There are two commands for SQL privilege. One is a grant and another one is a revoke. Let us dive deep into each of them. Now, granting privilege with grant command. Grant command is used to provide the privilege to the user or a particular role. It could be a reader role, it could be a finance role, or it could be any business specific role which you want to provide the privilege for. Syntax is very simple. You have to give a grant as a keyword, then what kind of privilege you're going to do or going to give, on which object, to which user or a particular role. To dive deep into the example, let us see this. Here we are giving access in the first command for user 1, okay, on employee table as a select privilege. So the user 1, whenever he logins to SQL Server or the SQL database, he can only select the data from employee table. He cannot insert or update any data into the table. Similarly, we have sales role. Whenever a sales role or who all the users which are assigned under the sales role will have access to order table for doing insertion and updating of the orders. This helps user to grant privilege for a particular object with particular privilege type. It could be select, insert, update, or execute. Now, like grant, we have revoke. Revoke privilege is nothing but if you have given access to particular user or particular group of role a particular privilege. But after some time, if the user goes out of the organization or if that particular role does not require any access, for that we revoke the access so that accidentally after some time if he or she tries to access the particular object, he will not be able to access. For syntax, we have revoke as a keyword. What type of privilege we want to revoke from the object, which is on object, from user name or role name. We have to specify this command for revoking the user access. For example, if we want to revoke the access from user 1 on the employee table, we just write revoke select privilege from employee table from user 1. This command will revoke the select access from employee table on from user from employee table for user 1. Similarly, Whenever we have to revoke access, we can write revoke insert update privilege on order table from sales row. This particular command will remove the access for sales role from order table with insert and update privilege. Now, indexing. What do you mean by indexing? Indexing is something with respect to a textbook. Whenever you open any book, it has an index to it. What it helps? It helps to find a particular topic or a particular page number, what it has very quickly. Similar to the textbook index or any book index, we have indexes in the database as well. They help us to locate a particular information in the table very quickly. They correspond to a particular row in a database. Now, to give you an overview example, let's say, for example, you have a table and it has multiple rows. Now, whenever it has multiple column as well. So whenever you create an index on one column, let's say for example ID, what it will do based on the index type, it will create a reference table for a non-cluster index. It will store ID and address. So let's say for example, here we have 1, here we have 2, and here we have 3. So it will store 1 over here and it will address to this particular location in the database. This helps the SQL query to retrieve the data faster. What are the different benefits of indexes? First, it improves the query performance. Second, it helps to retrieve the data more efficient and faster way. Third, it reduces the IO operation. So whenever we have specified the index, it helps us to read the data faster, due to which the IO operations are very minimal. It also helps in enhancing your data management. Whenever you are dealing with large amount of data, at that time, indexes play a crucial role in OLTP system or OLAP system based on the database design. Now, let us see some types of indexes. First, we have a cluster index. So cluster index is defined the order in which a data is stored physically in a table. It is normally recommended to have a cluster index on a primary key column so that the retrieval is very faster. Whenever the cluster index is created on a primary key table, like the example I have shown, instead of that, it arranges the data in storage like this. So let's say, for example, we have a table and we have a column ID as a cluster index, and it has many other columns. Now, what happens if we create cluster index on ID column is whenever we insert record 1, it's stored on location 101. And when we insert a record 2, it will automatically store the data in 102. Similarly, the third record will be stored in 103. So just keep in mind that cluster index is nothing but a physical sequential order in which a data is stored. So let's say, for example, if this particular row will take 12 units, so it will be 1013. Then it will be 1020, 24. Like that, it will be incremental. Similar to cluster index, we have a next index type, which is non-cluster index, but in the opposite manner. In the non-cluster index, what happens is whenever you create a non-cluster index on a particular column, it stores the address of a primary key in the reference table, or it stores the address of that particular row in the reference table, like we discussed in our previous example. Then we have unique key index. Unique key index ensures that the value in the index column are unique across the table. It can be either cluster or a non-cluster depending upon the column requirement. Then we have full text index. This type of index is optimum when searching large text box column, allowing for faster and efficient full text search. Like you have seen comments. Whenever you enter the comments, in order to search a relevant comment, we have to create a full text index on that comment column. Then we have a bitmap index. Bitmap index uses bitmap and is typically used in data warehousing environment. It is efficient for column with low cardinality. Low cardinality means whenever you have very few unique values. Useful in scenarios where large data set but a distinct columns like gender or status are there. Those columns can be can be created as an bitmap index. It will help the query to retrieve the data more efficient and faster way. Then we have composite index. Composite index is nothing but whenever we create an index on multiple columns, it is called as a composite index. It can be a cluster index or a non-cluster index, depending upon the requirement. At last, we have spatial index. Spatial index is nothing but it is used for storing the GIS information. Whenever we store the GIS information like the coordinates or a particular latitude and longitude, it is helpful to create the spectacle index. Let us see an example or a syntax of creating index. To create index, what we have to do is just write a keyword, create index, then the name of the index, then on again a keyword, and on which column we are going to create the index, that the table name and the column names. For example, we have create index idx underscore employee underscore name. This is the index name. On employee for column last name. This particular command will create an index on the employee table on last name column with name as idx underscore employee underscore name. Similarly, we have create unique index idx underscore order underscore id on order table for order id. With this command, we have created order id column as an index column with the name as idx order id. It is defined as a unique index. So no order in this table will be repeated for the order ID column. Now, let us see what do you mean by transaction control. Transaction control is nothing but whenever you have to execute set of statement together and it has to be all complete or none of them are complete. With the help of transaction control language, you can achieve this. There are a property of any DBMS system called ACID properties. ACID properties are nothing but atomicity, consistency, isolation, and durability. Atomicity means it ensures that the transaction is treated as single, even though you define multiple transactions. We will see an example for this. It helps either all the transactions are complete or none of them are complete. Whenever there is a failure while executing the transaction or a particular command, it will be cancelled and it will be as a previous state. Consistency. Consistency ensures that a database remains in a consistent state even after multiple transactions are placed. It maintains the data integrity and it enforces the constraint with the help of multiple types of constraint we have seen. Isolation. Isolation ensures that multiple transactions can be executed concurrently without interfering each other. However, if any particular transaction is dependent on a different object, it has to wait until the previous object or previous transaction which is using the same object completes. That helps the isolation. Durability. It ensures that once the transaction is completed, it is permanent. Even though if the system is failed after completing the transaction, the database will be in that particular state. All this acid property helps the transactional system to be consistent. To give you more background on transaction control, there are three main commands. One is begin transaction. This particular statement initiate the transaction at database level. Once this particular statement is initiated, we can write set of statement in order to be executed as a single set. It could be multiple delete, multiple update, or multiple insert. Later on, once all the statements are successfully completed, we can write commit. This tells the database that now all my transaction or all my records as are completed. Now save this, just like a control S. In this in the scenario where if a particular transaction is failed, let's say for example, if the second statement got failed, so whatever insertion I have done in statement 1 should not be submitted or saved. In order to do that, we can write a rollback command. This will undo all the work which was done for all these statements, and the database will be in its previous state or the initial stage. To give you more background, let us see an example. Here, we are performing a transaction on account where we want to remove the balance of one account and add it to another account. Now, what happens if the second statement fails? In this particular case, whatever balance which was reduced from account 1 will be restored. How the statements are executed are: first, begin try. It is a command where we tell SQL Server, try this particular statements. If these fails, go to this statement. Now, what happens is begin try. After begin try, we have initiated begin transaction T1. So we have initiated a transaction T1. After that, we are writing set of update statement. If both the statements runs successfully, at that point of time, we will run this commit statement, and it will be out of the loop. In case of failure, let's say for example, if this particular statement is failed, so it will throw to the begin catch block, and we will roll back the T1 transaction which was initiated in this particular statement. This will help to maintain the database consistency. Let us see some other features of SQL, which is view. Views are nothing but a virtual table based on a select query. This particular thing help us to encapsulate your data from certain users. Let's say, for example, if you want to give access to certain user for only selected number of column from the table. So instead of providing access to the whole table, you can write a view. Here is the syntax of view. You write it as create view, the name of the view as, and this is the start of the view and this is the end of the view. You can specify the select clause. Please remember, view has to be written only one select statement. It cannot return multiple select statement. If we want to return multiple select statement, we can either use a union to merge both the results together as a single statement, or if there is a dependency on two different tables, let's say for example, order header and order detail, where both the tables are required to show the order data. In order to do that, we can join those two tables, order header and order detail, based on the order ID, and we can select the result to the view. To give you an example, let us see how we can create and use the view. Let's say, for example, we have an employee table where we want to create a view to display all active employees. In order to do that, what we are going to do is select employee ID, first name, last name from employee table where status is active. Now, this particular statement will create the view called active employees. Now, in order to access the view, we can simply write select star from the view name, which is select star from active employee. This particular statement will indirectly run this compile query and give us the result. Views simplify the query and provide security on specific data. Let's say, for example, if the employee has a payroll information and we don't want to give the payroll information to any of the developer or any of the user. In that particular case, we can write the view just selecting all the non-payroll related columns and give the view access to that particular user or data analyst or anyone. Let us see the last topic of today's session, which is database normalization. What do you mean by normalization? Normalization is very important topic in the terms of OLTP, where you want the data to be fully normalized and the data insertion needs to be faster. In order to do that, we can define multiple normal forms, which is one first normal form, second normal form, third normal form. Now, to give you an idea, what do you mean by first normal form? In first normal form, whenever you have data in multiple columns, we have to remove and move them into multiple rows. For example, we have a order table where we have product 1, product 2, and product 3. Instead of having product data distributed across multiple columns, we have to move them into multiple rows. So let's say, for example, here we have customer 1, and customer 1 is purchasing three different products. So P1, P2, and P3. Instead of this, what we have to do in the first normal form is we have to convert this data into three different rows. First is P1, second row will be again customer C1 with product P2, and third again customer C1 with product P3. This is nothing but we remove the repetitive group into column, repetitive group into rows. Now, what happens if the database, the table is there in the first normal form? Then we can apply the second normal form. What do you mean by second normal form? It means that whenever we have data, let's say for example, C1, and it has product information. So it will have P1 with the product name, product type, and other details. Similarly, P2 with product name, product type, and other information. And similarly, P3. Whenever we have this kind of information with relevant information of the product is also present in the same table, what we have to do is we have to split this table. Now, how to split this table is we will write a customer ID as C1, C1, C1 for product P1, P2, and P3. However, all the functional information of the product data will be stored in the second table, which is P1, P2, and P3 with the relevant information. This will reduce the data redundancy on the single table. So let's say, for example, if we have similarly customer C2 access P2 and P3. So the data will be repeat in this table in the first normal form. If we split this data in the two table, it will automatically be not repeated in the single table. This is nothing but the second normal form, which helps us to remove all the non-key attributes into a fully functional dependent table. Now, what do you mean by third normal form? In order to normalize the data into the third normal form, it has to be first apply the first and second normal form. For example, let's say for example, we have a customer data with the address details. So the address details cannot be stored in the customer tables alone, except for the particular address, like the house number or the apartment detail. We have to store this particular data in to the different table. It means that if we have the customer record identified with the ID C1, it helps us to get the address of A1 with its detail like city, state, country. Now, in the third normal form, what we do is remove the transitive dependency of the table and move this particular data into separate table. This is nothing but the third normal form. Now, let us see the benefit of using normalization. Normalization helps us to minimize the data redundancy and avoids update anomalies. Since we splitted the data into two different tables, the redundancy will be reduced. Like, for example, the order table, we were instead of having the product data multiple times, we just refer the product key to the order table. Similarly, it helps to improve the data integrity and consistency. Now, since we have defined the order table, we are not going to add the product each and every time a new product. We will refer the product from the product table instead of creating the product on its own. It helps in efficient data retrieval and better organization. For example, whenever we are retrieving the data, we can directly join the tables and retrieve the data quickly. And the last thing is it it will help us to have the optimum storage. Let us see the best practices. Best practices are nothing but whenever we are using a SQL privileges, we need to make sure that we are granting access to only required set of user. We should not provide access to many of them. We need to define a role whenever we have to specify access to the multiple set of people. We can create a role in SQL Server for a particular usage. Let's say, for example, we can create a finance role. So all the finance team member can have access to the finance role. Similarly, when creating the indexes, we need to create index on a required column only. If we create multiple indexes which are not required, it will slow down the process of data insertion. Because let's say, for example, you have created a primary key with a cluster index and you have created another five index on that same table. What will happen is it has to reorder the primary key and it has to restructure those indexes. Hence, it will take time for your insertion, updation, as well as deletion. Transaction control, whenever you're using, make sure that you commit the statement, because unless and until you commit the statement, it will be not saved. And if you forgot or if you do not handle it properly, this will be a disaster for you, because you will not be able to identify where exactly you made the mistake. Hence, recommend to use the transaction control statement properly. While using views, it helps you to abstract the data. But what happens whenever the column is added to the primary table? We have to rebuild the view in order to get those data into the view. Let's say, for example, you have created a view with a condition like select star from a particular table, and you write a condition as data from date and to date. And later on, you added a particular column onto the table. At that point of time, you will see the view is not retrieving the new column. For that, you have to refresh the view or rebuild the view in order to get the new data or the new column. Lastly, database normalization helps you a lot for optimum storage, faster data retrieval, or faster data insertion. But based on the requirement or based on the database design, you have to decide which normal form you have to go. Either you have to go in the first normal form, second normal form, or sometimes you have to go third normal form or more. This will come with experience. So I would recommend you to practice the database query on huge dataset. To conclude today's session, we have covered data control language, which is DCL. We have seen indexes, types of indexes, and the syntax. We have seen transaction control languages and the syntax. We have seen views, what is the use of the views, and the syntax and the examples. At last, we have seen what do you mean by database normalization? How does it helps you to optimize the database structure? And we have seen the best practices. To provide you more reference, you can go through the book SQL in 10 minutes, Sam Teach Yourself, or Learning SQL. You can also refer to the official documentations from the specific database management service provider like MS SQL, MySQL, PostgreSQL, or MongoDB. For any of your comments or queries, you can either comment on this particular video, or if you have any specific question based on your specific need, you can email us to inquiry@skillsacademy.com. Thank you. We will come up with the next session on different technology. See you soon. Goodbye.